Hello, welcome to ANS Solver. This is the fourth part one of the question. So what we need to do is we need to write root 6 sine x plus cos x in the form of r sine x plus alpha. And this is basically between 0 to 90 degrees. So we need to state the value of r and give alpha to 3 decimal places. So now if you notice here, this is basically your sine a plus b compound angle formula. So I can write this basically as r into sine x cos alpha plus cos x sine alpha, which can be written as r sine x cos alpha plus r cos x sine alpha. Okay, now I know both of these are equal, so I can simply compare. Comparison basically means I have a sin x here, I have a sin x here. Okay, the coefficient of sin x here is simply r cos alpha, so I can write r cos alpha here. It is equal to the coefficient of sin x here, which is root 6. Okay, in the same way I have cos x here, I have cos x here. The coefficient of cos x here is r sine alpha, which is equal to 1, which is the coefficient of cos x. So now I can write this as cos alpha equals to root 6 by r, which gives me my answer as sine alpha equals to 1 over r. So now what I can simply do is I can make a right angled triangle. This is what I recommend you always do. It makes the process much more simpler. So I have a 90-degree here. Let's say this angle here is alpha. Now I have cos alpha. So cos basically means adjacent over hypotenuse. So my adjacent here is root 6. So I can write root 6 here over my hypotenuse, which is r. So r comes somewhere here. Now sine alpha, which basically means opposite over hypotenuse, I can say my opposite is 1 and my hypotenuse is r. So now to find r, I can use basic Pythagoras theorem to get the square root of 1 square plus root 6 the whole square. So I can write this as 1 plus 6, which is basically root of 7. Okay, now what I simply need to do is I need to find alpha. So what I know is that sine alpha is equal to 1 over r. So I can say sine alpha is 1 over root 7. Make sure you are on the degree mode because they have given the domain in degrees, and do sine inverse of 1 over root 7. So when you do that on the calc, okay, in the degree mode, even I'm doing it, give me 1 second, you get your answer as 22.208, the 3 decimal places as they wanted. So now you can write this as root 7 sine x plus alpha, which is x plus 22.208. Okay, which is basically the final answer of the question. Now hence solve the equation root 6 sine 2 theta cos 2 theta equals to 2. Okay, so now if you see, I know it's basically this equation, but instead of x they have used 2 theta. Okay, so what I basically need to do is I know this can be written like this, but instead of x I'll put 2 theta. So I can write this as root 7 sine 2 theta plus 22.208 which is equal to 2. Now I can write this as sine 2 theta plus 22.208 equals to 2 over root 7. Okay, so now what I can simply do is I can write this as, okay, now before that we need sine to be positive. I know sine is positive in the first quadrant and the second quadrant in ASTC, correct? So now I need the value in the first quadrant, which is basically sine inverse, okay, of 2 over root 7. Okay, when I do sine inverse of 2 over root 7, the value I get is simply 49.12, comma, for the second quadrant I know I need to do 180 minus theta if theta is the value in the first quadrant. So I can simply do 180 minus 49.12 to get my answer as 130.893. Now I can write this as 2 theta equals to 49.12 minus 22.208, comma, 130.893 minus 22.208. So now I can say 2 theta is equal to 49.12 minus 22.208, which will basically give me 26.912, comma, 130.893 minus 22.208. So the value I get is simply 108.685. Now I can write this as theta equals to 26.912 over 2, comma, 108.685 over 2. So theta can basically be written as 26.912 over 2, which I know is simply 13.5 degrees, comma, 108.685 over 2, which will give me 54.3 degrees to 1 decimal place. And this is the final answer of part 2.